Welcome to G Fun Facts Online. Today we are stepping into the vast, silent theater of the cosmos to talk about the clockwork of the heavens. When you look up at the night sky, the planets might look like wandering bright stars drifting against the constellations. But to an astronomer, these movements are the ticking gears of a grand celestial machine, governed by the laws of gravity and motion. Specifically, we are going to dive deep into planetary oppositions and orbital alignments. These events are more than just pretty photo opportunities. They are the keys that have unlocked the secrets of the universe for humanity. From the ancient Mayans who timed their wars to the cycles of Venus, to the Voyager probes using a rare alignment to fling themselves into interstellar space, the alignment of worlds has shaped our history and our reality. So let's break down the mechanics, the history, and the science, and then I will give you a masterclass on how to observe and photograph the spectacular events coming up in 2026. To understand why planets align, we first need to understand the stage they are dancing on. Our solar system is essentially flat. The 8 major planets orbit the Sun in a thin disk called the ecliptic plane. Now, while they all travel in the same direction, counterclockwise if you were looking down from above the Sun, they move at vastly different speeds. Mercury, the inner messenger, races around the Sun in just 88 days. Meanwhile, distant Neptune takes a plodding 165 years to complete a single circuit. It is this difference in speed that creates the shifting geometries we see from Earth. We are on a moving platform, a spaceship called Earth, that orbits the Sun once every 365 days. As we race around the track, we are constantly overtaking the slower outer planets like Mars and Jupiter, and we are constantly being overtaken by the swifter inner planets Mercury and Venus. The term alignment is often used loosely, but in astronomy, it has a precise name: syzygy. Pronounced syzygy, it comes from the Greek word for yoked together. A syzygy occurs when 3 or more celestial bodies align in a straight line. You actually know this better than you think. When the order is Sun, Moon, Earth, we see a new moon. When the order is Sun, Earth, Moon, we see a full moon. But this applies to planets too. When Earth sits directly on the line, connecting the Sun and an outer planet, we call this event opposition. Imagine looking down on the solar system. The Sun is in the center. Earth is a dot on its orbital circle. Jupiter is a dot on a larger outer circle. Opposition occurs when Earth passes directly between the Sun and Jupiter. From our perspective, the Sun sets in the west, and Jupiter rises in the east. It is the planetary equivalent of a full moon. The planet is fully illuminated, visible all night long, and crucially, this is when the planet is closest to Earth, appearing larger and brighter than at any other time. This is different from conjunction, which is when the planet is on the far side of the Sun, hidden by the glare. Also, keep in mind that only superior planets, those from Mars outward, can reach opposition. The inferior planets, Mercury and Venus, orbit inside our path, so they can never be behind us relative to the Sun. One of the concepts that confused ancient astronomers the most was retrograde motion. Normally, planets drift eastward against the background stars, but around the time of opposition, a planet will appear to slow down, stop, and move westward or backwards for a few weeks. This is an optical illusion caused by parallax. Think of it like a highway. Imagine you are driving a fast car, which is Earth, and you pass a slower truck, which is Jupiter, in the outer lane. As you approach the truck, it looks like it is moving forward. But at the moment you pass it, the truck appears to drift backward relative to the distant mountains, simply because you are moving faster. That backward loop happens exactly at opposition, proving that Earth is overtaking the planet. Long before we understood this mechanics, humans looked to these alignments for meaning. For the Maya civilization, astronomy was a survival tool. Their obsession was Venus. They knew that Venus repeats its cycle every 584 days. They built observatories like El Caracol at Chichen Itza, with windows specifically aligned to Venus setting points. To them, Venus was a war god. Its first appearance as the morning star was a dangerous omen. Maya rulers would actually plan Star Wars ritualized raids to coincide with these alignments, believing the planet's position guaranteed supernatural support. In ancient Babylon, priests kept detailed diaries of planetary positions for centuries. To them, Jupiter was Marduk, the king of gods, and Mars was Nergal, the god of war. When Mars and Saturn approached each other in a conjunction, it was seen as a clash of hostile forces. They had tablets warning that when Mars approaches the Scorpion, the prince will die by a scorpion's sting. It was an early form of data science, trying to correlate the sky with earthly events. Perhaps the most famous panic occurred in Renaissance Europe. Astrologers noted that in February 1524, all the known planets would align in the constellation of Pisces. Since Pisces is a water sign, the fish, astrologers predicted a catastrophic biblical flood. Wealthy citizens sold their homes near rivers and moved to the mountains. A German nobleman, Count von Igelheim, actually built a 3-story ark on the Rhine River. When February 1524 arrived, it rained a little, but the world did not drown. The Count was reportedly stoned to death by a mob who wanted to board his art when the rain started, but the apocalypse itself was a no-show. This non-event helped slowly erode the credibility of astrology in favor of astronomy. And that brings us to the hard science. Planetary alignments have provided some of the most critical measurements in physics. Before the late 17th century, most scientists believed the speed of light was infinite. The proof that they were wrong came from an alignment. In 1676, the Danish astronomer Ole Romer was observing the moons of Jupiter, specifically Io. Io is a reliable clock, orbiting every 42.5 hours. Romer expected to see Io disappear behind Jupiter at perfectly regular intervals, but he noticed a drift. When Earth was approaching opposition, getting closer to Jupiter, the eclipses happened earlier. When Earth was moving away, they happened later. Romer realized the clock wasn't broken. The information was just taking longer to arrive. When Earth was on the far side of the Sun, the light had to travel an extra distance equal to the diameter of Earth's orbit. He calculated that light has a speed limit. This discovery, made entirely by observing orbital mechanics, laid the groundwork for Einstein centuries later. Later, in the 18th century, alignments helped us measure the size of the solar system. Astronomers used the transit of Venus, when Venus passes across the face of the Sun, to calculate the distance to the Sun using trigonometry. This led to global expeditions in the 1760s, including Captain James Cook's voyage to Tahiti. It was the Apollo program of the 18th century. In the 20th century, we moved from watching alignments to using them. In 1964, Gary Flandreau at NASA's Jet Propulsion Laboratory discovered a rare alignment of Jupiter, Saturn, Uranus, and Neptune that happens only once every 175 years. This offered a unique opportunity for a gravity assist. A spacecraft could use Jupiter's gravity to sling itself towards Saturn, then to Uranus, and so on. This birthed the Voyager program. Voyager 2 launched in 1977 and rode this alignment perfectly. It stole a tiny bit of angular momentum from Jupiter to accelerate itself, visiting all 4 gas giants in just 12 years. Without this alignment, a direct flight to Neptune would have taken 30 years and required impossible amounts of fuel. So why do these alignments happen? Is the solar system chaotic? No, it is structured by orbital resonance. This occurs when orbiting bodies exert regular, periodic gravitational influence on each other. The best example is Jupiter's moons, Io, Europa, and Ganymede. For every 4 orbits Io completes, Europa completes exactly 2, and Ganymede completes exactly 1. This is a 4 to 2 to 1 resonance. This rhythmic tugging pumps the orbits, creating massive tidal friction inside the moons. This friction is what melts the interior of Io, making it the most volcanic body in the solar system, and it keeps the subsurface ocean of Europa liquid, making it a prime candidate for life. Without this alignment, those moons would likely be dead, solid rocks. Now, let's look forward. For the amateur astronomer, the coming years are going to be incredible. After a quiet period, the major planets are moving into excellent positions. Mark this date, January 10th, 2026. On this day, Jupiter will reach opposition in the constellation of Gemini. This is special because it is a winter opposition in the northern hemisphere, meaning the planet rides high in the sky, well above the blurry air near the horizon. It will shine at a magnitude of -2.7, far outshining the brightest stars. With binoculars, you will see the 4 Galilean moons. With a small telescope, you will see the cloud bands. With a 6-inch telescope, you can see the Great Red Spot. Also in 2026, the plane of Jupiter's moons will align with Earth, leading to mutual events, where the moons eclipse each other. These are rare events that give a 3D sense of the system. Then, on February 19, 2027, Mars will reach opposition in Leo. It will be high in the northern sky, offering sharp views of the Syrtis Major and the North Polar Ice Cap. And keep an eye out in late February 2026 for a planetary parade where Mercury, Venus, Saturn, and the Moon will cluster in the pre-dawn sky. If you want to capture these moments, we are living in the golden age of astrophotography. The secret is a technique called lucky imaging. Here is the masterclass. When you look through a telescope, the image shimmers like it is underwater due to our atmosphere. If you take a single photo, it will be blurry. So you don't take a photo. You use a high-speed planetary camera connected to a laptop to shoot a video at 100 frames per second. You record for about 60 to 120 seconds, gathering thousands of frames. Then, you use software like AutoStockard to analyze every frame. The software picks the lucky 10 or 20% of frames, where the atmosphere was perfectly still for a split second, stacks them on top of each other to reduce noise, and then you use software like Registacks to sharpen the details. That is how backyard astronomers produce images today that rival professional observatories from the 1980s. Looking even further into the future, on September 8, 2040, we will see a superconjunction where Mercury, Venus, Mars, Jupiter, and Saturn cluster within a circle of just 9 degrees. And if you want the ultimate alignment, you have to wait until May 6, 2492. On that date, All 8 planets will be closer together in longitude than they have been for thousands of years. It won't be a perfect straight line, but it will be a grand cosmic meeting. Today we even use alignment to find aliens. The primary method for finding exoplanets is the transit method, watching for the tiny alignment when a planet crosses its star. We have gone from fearing alignments as omens of doom to using them to map the galaxy. Planetary opposition and orbital alignment are the heartbeat of astronomy. They are the moments when the clockwork of the solar system reveals itself. So, on January 10, 2026, step outside, look up at the blazing jewel of Jupiter, and remember, you are witnessing a dance that has been going on for 4.5 billion years, and you are the universe observing itself. Thanks for listening to G Fun Facts Online.